students. Okay, we are in week number 11 of the online learning, and we are starting a whole new topic. Well, it's not a whole new topic, we're still in the energy, forces, motion. We're done with energy now, and now we're moving to forces. Okay, so this is a very introductory lesson on forces. Okay, we're going to talk about all kind of types of forces that you need to be aware of. And then in the following lessons, we'll start investigate a little bit more, getting into depth of some of the forces we're going to mention today. So first of all, what is a force? Okay, this is very difficult to do it like this. This is where I really enjoy the input that you give, and in class we would be discussing, and I would love to hear what your thoughts about what is a force. Fortunately, we have to teach like that, so I'm just going to tell you. Okay, so a force is a push or pull that we apply on an object. Okay? Now, more importantly, what can it cause in an object? What can it cause? What are the effects of the force? And it turns out that there are three effects. One thing, it can change the speed of an object. So if, let's say, you're in the car, and the engine push the car forward. So what can happen to the car? It's not just moving. It's not enough to say it makes an object move. It actually accelerates the car. It speeds up the car. So push, or force, can either speed up the car, make it go faster, or it can slow it down. Okay, so when you press onto the brakes, okay, you apply the opposite force, and now it slows you down. So when we apply a force on an object, the speed of the object can change. Okay? It's either going to accelerate or decelerate. Okay, so that's the first thing that can happen. The other thing that can happen, it can change the direction of motion. So if imagine I've got a little string, and I'm holding a bucket at the end of the string, and I'm turning that bucket. You know that my arm has to work, has to pull the bucket towards me at all given moment. Now the speed of the bucket could be the same. The speed might not change, but the direction of that speed changes. So that the bucket will go in this way, and it will go that way, and that way, so it can change the direction of the bucket. The same thing if you think about it when you're driving in a car, okay? If you drive in the car, okay, and then you turn, let's say you turn to the left, okay? I remember I used to play that with my sister and brother. I'm sure some of you play that as well. As soon as, we would be in the back of the car and we turn there, I would just squash my sister on this side. You guys play that? Okay, so there's a force that pushes us, okay, to one side. Okay, why is that force happening? Because the car is moving, changing direction. The car's moving, could be moving in the same speed, okay, but there's a force pushing us. You can feel actually the door, even if you don't have your brother or sister next to you, you can feel the door is pushing you into one direction because you're changing direction. Okay? So, it can change the speed, or can change the direction. The third thing that can happen, we can change the shape of an object. So, for example, if I take this bit of paper, I can apply force on it. Now, it didn't move anywhere. There is no change in speed. There is no change in direction, but there is a change in shape. Okay? So, the same thing with a spring, okay, or elastic. Second, okay? You can see that there's an elastic here. By applying a force, I'm changing the shape. Okay? So, that's the third thing that force can do. When I finish, just pause me and copy. Everything is written here. So we've got forces can change speed of object, direction of movement, shape of an object. Okay? Whatever you do, don't say it can make an object move, because that's not specific enough. It can change its speed. Right. We measure force by newtons. Okay? Newton is the unit of force, just like meter is the unit of length. Newtons is the units of force. Named after Isaac Newton, that gave us the whole theory of gravity. Okay, then usually we won't write newtons, like we don't write meters. Meters we write the little m. Okay, and newtons we write capital N for newtons. Okay, we use a force meter. Unfortunately, I don't have one here, but I'll show you guys when you come back, and we'll hopefully do an experiment or two. Okay, a device that measures the force. Okay, is basically a spring. Okay, so I don't know if you ever went overseas and maybe weighed your luggage to see if you're under the restriction. Okay, what you use is called a force meter. Okay, and it's like a hook that you connect onto whatever you want to weight, and it gets bigger, and and then you can read how much force, how much does it weigh. Okay, weight is a type of force, okay? And all it is really is spring. Okay, the more it stretches, the more force it creates. Okay, now what kind of forces are there? Now it turns out that there's two main families of forces: non-contact forces and contact forces. Okay, now I think let's start with the contact forces. Okay, contact forces means that there has to be two objects that apply force on each other have to be in touch. Okay, so we'll start with friction. Okay, you know that if you push, let's say, a box or anything on the floor, okay, to make it move, you have to keep on pushing it. If you stop pushing it, okay, it will slow down and stop. Why? Okay, not because you have to apply force to an object to move. We will talk about that later on. But if you don't apply any force on it, there will be friction in the other direction. It will slow you down. Okay, when two objects slide against each other, okay, they apply friction on each other. Okay, what does this friction mean? Okay. Let's take, I don't know, you can take this pin and you slide it on the table. It will go for maybe a meter and then it will stop. Okay? Why? Because of friction. Now this pin, the surface looks very smooth. Okay? The table looks pretty smooth as well. Okay? But I'm sure you understand that if you look, or you believe me, that if I say we look in the microscope, you will see that it's not smooth and it's actually quite bumpy. Okay? And that's in the microscopic level. Okay? Now when these bumpy surfaces slide against each other, they bump against each other. Okay? And that's what causes friction. Okay? They collide with each other. So friction is the force that resists motion between two objects. Force that resists motion between two objects. Now, a push and a pull, okay, you can either push an object or pull an object. If I push this pen now, we call that a push. If I pull it, it's called a pull. Tension. Tension is force that we normally talk about when we have a rope or a string. So if I hang something on the rope, okay, and the rope, the something, let's say I hang, I don't know what, a book by a rope, okay, by a string, okay, gravity pulls it down, but the string pulls it upward. We call that tension. Okay, water and air resistance. Okay. If you've got a paper falling in the air, okay, it will fall slow. Why? Air resistant pushing upward. Okay? What is air resistant, if you think about it? Okay, so if you were in class, you can just do it now. Just move your hand up like that. You can feel this wind. And there is no wind. Okay? I'm sure you've done it in the past. Driving in the car, okay, you open the window, okay, and you put your hand a little bit out. Okay, very dangerous. If you do it, just do it like a few centimeters. You can lose your hand if you do it too far. Okay, you'll feel that wind. Okay, what is that wind? It's not wind. There is no wind. Okay, you're bumping against the air particles. When I move my hand like that, okay, we already know from the beginning of the year the air is something. It's not nothing. It's full of these tiny little particles: oxygen, not nitrogen, carbon dioxide. Okay. And they like tiny little balls. And as I move my hand, I bump against them. Okay? I push them away, but that means they push me away as well. Okay? So it's kind of like friction, but in the gas. Okay? So air resistant is kind of like friction in the gas. Okay? Cool. Water resistant, the same thing, but in water. Okay? So if some of you are swimmers, okay? We had a fantastic swimmer in class. Unfortunately, he left us. Okay, but you know that swimmers have to do a lot of, they have to have the right technique to make themselves very small to reduce the water resistance. The same thing as air resistance. When you're moving through a liquid, okay, you're pushing against these liquid particles, and that means they're pushing against you. They slow you down. Okay, so you have to be very aerodynamic, or hydrodynamic, you'll call it, to minimize that water resistance. Upthrust, right. Upthrust is a general name for forces that are pushing us up. So, I don't want to get into too much of what's the origin of that force, but if I was chatting to somebody, I can't remember who it was, but airplanes, what keeps airplane and birds in the sky? Yeah, grade 7 asked me that. Okay, the answer is upthrust. Okay, so the air can actually push you up. and it can be as strong and even stronger than the weight. Okay, that's how birds fly. Okay, so we call that upthrust. Another place where we see upthrust is in the water. So when I jump into the water, weight pulls me downward, but I don't sink. Okay, if I breathe, okay, I don't put any water in my lungs, okay, I will actually float. Why? Because gravity pulls me down, but the upthrust from the water pushes me up. Okay, why does the water push me up? That's a good question. We're not going to get into that right now. Okay, yeah, but don't get confused. Don't get upthrust and air resistance confused. When a paper falls down, okay, it's the air resistance that pushes up. It's not called upthrust. Okay, so don't get confused here. Reaction force. That's probably the hardest one to understand. Okay, and I'll use my chair for this. Okay, I'm standing on a chair. Okay, now there's a force that pushes me down. That's gravity, isn't it? My weight pushes me down. But if that was the only force, then I will come crashing down through the chair. So there must be another force pushing me up, isn't it? Okay, that force is called reaction force. Why is it called reaction force? Because the chair pushes me up only when I push it down. Why am I pushing it down? Because the weight wants to pull me downward. So that means I'm pushing onto the chair. Imagine if instead of the chair, it would be, let's say I would stand on your shoulders, okay? Then you'll feel my force downward, okay? But that means you're pushing me upward. As long as you don't fall and collapse and break, you're pushing me upward. So we call it a reaction force, okay? I push the chair, and that means I push the chair downward, and that means the chair pushes me upward. It's a reaction force, okay? Also works horizontally. If I push onto the wall here, okay, I'm pushing onto the wall, okay? If I don't find myself in Mrs. Bradley's classroom, that means that the board and the wall push me in the other direction. It creates a reaction force, okay? Sometimes we call it normal force. You can call it whatever you want. Why normal force? Normal, you already know from maths, is 90 degrees, isn't it? Normal is an angle of 90 degrees. Now, if I push onto the chair in this direction, okay, the direction that chair pushes me up is in that direction. It's 90 degrees to the surface of the chair. This is the surface of the chair, and I'm standing on the chair. The chair pushes me 90 degrees to the surface of the chair, not in any other angle, always 90 degrees. So that's called a normal force. If I'm pushing onto the wall in this direction, this is the surface of the wall pushes me again in 90 degrees to the surface of the wall. Okay, so 90 degrees. Right, non-contact forces. So all these forces, they needed some kind of touch, a contact between the two objects, between me and the board, between me and the air, between a pen sliding onto the table. There's always touch. Okay? Some forces actually don't need any contact, and that's quite fascinating. These are the really interesting forces, in my opinion. So the most common one you know is gravity. Okay? Right? This pen, okay, is pulled by the earth. Okay? The earth is not touching it. Okay? But gravity is the force that the earth pulls the pen towards it. I don't know if you ever thought about how does it actually happen? Okay, and by thinking about these things, this actually made Einstein come up with one of the most important theories, or one of the most beautiful theories in physics, general relativity. How does the earth know that the pen is there? And how does it create that force from a distance? He calls it action from a distance. Okay? So weight or gravity, we will call it either weight or gravity. Electrostatic, we're going to have a lesson about that. Electrostatic is electric force that two charges will feel. Just to give you, we will have a proper lesson about it, but if you ever walked maybe and then touched your car and you got zapped a bit, that's because of electrostatic force. Okay? If you maybe on a very dry day, your hair suddenly went like this, okay? If you have straight hair and it just went like that, that's electrostatic forces. But we will learn about them later on properly. Magnetic force, magnets, north and south pole will attract each other. Same poles will repel each other. These are called magnetic forces. The magnets don't need to touch each other to apply that force. Okay, so again, we will have In fact, we will have lessons on all of these. Okay? So that's about forces. Just pause me now. Copy that. That's it. That's our first lesson. Cheerio.